All right, so the question asks to use the trapezoidal rule and Simpson's rule to find the definite integral for this function e to the x over 1 plus x squared dx, um, ranging from 0 to 2, and then with the number of shapes being n equals 10. So to go back to the definition of the trapezoidal rule and Simpson's rule, so trapezoidal rule is you take your delta x divided by 2, and then you multiply it by this sum. So the endpoints, x sub 0 and x sub n, based on the number of shapes you got, they're not going to be doubled. Everything in the middle gets doubled, though. So you have x, so f of x1 plus f of x2, these are all multiplied by 2. And so you get your delta x by taking the range of your integral. So this goes from 0 to 2. So that would be, you would put 2 in for b, 0 in for a, and you divide it by the number of shapes that you're making. In this case, it's 10. And then your x sub i's, so like with x sub 0 is going to be where your I equals 0. You get that by taking your lower bound, which is a, and adding I times your delta x. So that's the trapezoidal rule down here. The Simpson's rule, this is derived from using parabolas to approximate the curve. And remember, Simpson's rule can only be used with even numbers. That's not a big issue here because we already have n equals 10. That's an even number. But just for future reference, you can't use this for an odd number like 9. And so you get your delta x divided by 3, and then it's multiplied by the sum. And just like before, the endpoints, f of x sub 0 and f of x sub n, are not multiplied by anything. But then the middle ones alternate by being multiplied by 4 and 2. So all the odd x sub i's rather, so x sub 1, x sub 3, etc., they're going to be multiplied by 4. And then your x sub 2's, x sub 4's, they're going to be multiplied by 2. So that's the difference between these two algorithms for calculating these approximations for the integral. So here's our delta x. We take our upper bound 2, subtract 0, divide by 10, and that reduces down to 1/5, or in decimal form 0.2. And so the way you're going to solve this is you're going to take 0.2 divided by 2 for the trapezoidal rule, and you're going to multiply it by the sum of the function f at 0. You're going to get f at 0.2, multiply that by 2, f at 0.4, multiply that by 2, on and on and on until you get to the end where it's just f of 2. And this is the function that you're going to be plugging in, the e to the x over 1 plus x squared. So you're just going to evaluate that at all of these different inputs. And then for the Simpson's rule, you do pretty much the same thing, except it's 0.2 over 3. And then you also have differences in the middle for what you're multiplying by. F of 0, you just evaluate this at 0. And then you take 4 times this function evaluated at 0.2. Then 2 times the function evaluated at 0.4. Then 4 times the function at 0.6, etc. And then you get to 2 times 1.6, or the function at 1.6, 4 times the function at 1.8, and then just f of 2 by itself. No multiplying by 4 or 2 at that point. So this should give you enough information that you can start to solve this problem. Let me know if you get stuck somewhere, and I hope this helps.